Okay, here is a work problem. We're talking about two people working on a job. So following a severe snowstorm, Ken and Bettina Reeves must clear their driveway and sidewalk. Ken can clear the snow by himself in 2 hours, and Bettina can clear the snow by herself in 7 hours. After Bettina has been working for 1 hour, Ken is able to join her. How much longer will it take them working together to remove the rest of the snow? Okay, so this is going to be one of those work problems. So let's set up a chart and see what we have. Okay, I've got two different people, Ken and Bettina. I'm just going to use their initials for this problem. All right, and let's set up a chart, things that we know. First of all, the rate at which they work. Okay, so going back to what we talked about before, if Ken can do the job in 2 hours by himself, that means after 1 hour, he has completed 1/2 of the job. Same thing for Bettina. If she can do the job in 7 hours, that means after 1 hour, she can complete 1/7 of the whole job. So that would be their rate, how fast they can work. Okay. All right, the next thing is their time. Okay, how much time are they spending? Okay, this is going to be their total time, too, the total time each individual person is spent working. Okay. So going back, reading that problem one more time, how much longer, after Bettina has been working for 1 hour, Ken joins her, and then how much longer? So the point is Bettina's already been working for an hour. So if Ken joins her and then they keep working, they're going to continue working for X many more hours. That's the thing that we don't know. Okay, but again, Bettina has already been working for 1 hour, so her total amount of work would be X plus 1, that additional hour that she has been working. Okay. All right, and then the next thing is going to be the amount of the job. See, I probably won't be able to fit this in here, but that right there would be the amount of the job that they have completed. All right, so it's going to actually go right back to the same thing that we dealt with speed. All right, distance equals rate times time. Okay, same exact formula works for the amount of a job completed. So the amount still equals the rate times time. It's the exact same idea. So we can go back and finish filling in our chart. So Ken, his rate is 1/2, his time is X. So that means his amount would be 1/2 X. All right, similarly for Bettina, her rate was 1/7. Her time was X plus 1. Okay. All right, so that fills in the chart, and then we're going to have to go back and be able to set up an equation for this. So each one separately, they're doing different parts of the job. Okay, the point is they're not going to stop until the job is done. So you add up whatever they do together, and there will be one complete job finished. Okay, so that's what we're going to do. I'm going to go ahead and add up what they've done. So we will add the 1/2 X plus the 1/7 X plus 1 equals one complete job done. Okay, again, we're adding up what they've done, and it equals one complete job. Okay, and then we'll go ahead and solve. Okay, from here you can stop thinking about snow. It doesn't really matter. Point is we can solve the algebra. Okay, I'm going to make that a 1/1. Look at this to find an LCD to eliminate the fractions. I only have 2 fractions, which makes it easier. I only have 2 and 7 in my denominators. So my LCD will be 14. So if I just put a 14 on top of all the fractions on both sides of the equation, then we can simplify this equation. So this will turn into 7x plus 2x plus 1 equals 14. Don't forget to multiply the right-hand side by 14 as well. That will always change that number. Right, and then we can go back through, do the same thing as you would normally do for solving for x. Distribute, combine your like terms, isolate the variable. 7x plus 2x plus 2 equals 14. Combining my like terms, I'm going to give me that 9x. I'm going to go ahead and do this in the same step and actually subtract this loose number of 2 to both sides, just because that would be easier to do in the same step. So that will give me 9x equals 12. Then you divide both sides by 9, and you'll get x equals 12/9, which certainly can reduce to 4/3 or 1 1/3 if you'd rather have it like that. Okay, all right, so we got x equals 1 1/3. What does that mean? All right, let's go back and look at what we had. Okay, going back here, if you notice, x right here was the time for Ken. Okay, so x was the time for Ken. So going back and read the question, after Bettina has been working for 1 hour, Ken is able to join her. How much longer will it take them working together to remove the rest of the snow? So the point, it's asking for how much time Ken is working, since he didn't help that first hour. So x was what was in question. X is the time for Ken. So that means my final answer would be 1 1/3 hours is how long it's going to take them. Ta-da!